Alright, I'm going to be talking about problem 8160. So 8160 offers us the information that we have two graphs that intersect at a certain point. So notice that we have y equals log base 2 of x minus 1. And we have y equals x to the third minus 4x. And then they go ahead and they tell us that they intersect at two places, 2, 0, and 1.1187, negative 3.075. And so then from there, we want to figure out where is it true that, let me find the right color, log base 2 of x minus 1 is equal to this other expression, x to the third minus 4x. So we know that that's going to be true. At the same places, that's the same way that we would have solved this system. The only difference is that in this equation, rather than caring about both x and y for the solutions, we only care about the x values. So essentially, they've already solved the problem for us, they just gave us more information than we needed. So all we need to look at is the x values. So x equals 2 is going to make it true, and x equals 1.1187 will also make it true. The other question you had was about 8163. So let's go over that one. So what we want is to think about the square root of negative 7 times the square root of negative 7. Part A, how do we get negative 7? So recall that this is going to be the same as I root 7, right? I takes care of that negative portion times I root 7. We can simplify that. We'll get I squared, and root 7 times root 7 is just 7. Then we can remember that I squared is the same as the square root of negative 1 times the square root of negative 1. So we're going to get negative 1 times 7, which is negative 7. For part B, this is a common misconception that people want to apply to complex numbers, when in reality, it only works for real numbers. So when you have the square root of negative 7 times the square root of negative 7, what's her name? Londa wanted to say that that's the same as the square root of negative 7 times negative 7. The square root of 49, which is just 7. But remember, this is wrong because we already got this answer. So to avoid this mistake in the future, what you want to consider is that this rule that the square root of a times the square root of b is the square root of ab only works when a and b are positive. Right, and that's kind of part D as well. So another thing to consider would be that consider the imaginary part, I, before simplifying. So just to help it sink in a little bit more, let's look at if you have the square root of negative 5 times the square root of negative 5, then we want to first consider the imaginary part, so I root 5 times I root 5 Remember that I is accounting for the negative part, which is I squared times root 5 times root 5 is 5. Negative 1 times 5, that would be negative 5 as our answer. All right, hopefully that helped. Thanks for asking, Stasia.